Welcome to my talk on ESAPI. I will advise you that this is an extended version of the talk that I gave at the 20th anniversary presentation back in September. So if you already been to that and there was another talk you were interested in, you might want to slide sideways to one of those other talks. I'm not trying to discourage you from listening, but just fair warning. All right, so first thing, before anyone gets the urge to take copious notes, I want to let you know that I'm going to, just take a screenshot of this and basically give you all the important stuff to remember. And then sit back and relax with your favorite beverage, because I'm going to upload the slides on my GitHub. And let's see. Also, I am going to, Charles mentioned Hoover in the Q&A section. I will promise that I will write answers to any ones that I do not have time to reply to during this presentation. So, or you can also contact me at the email listed here, or DM me on OWASP Slack or on Twitter. So first of all, basically, you're looking at this slide and you're like, well, duh, thank you, Captain Obvious, right? Let me say that I did development for, or either exclusive development or a mix of development and AppSec for 30 years. And before I realized all the nuances that were involved here, especially in that first bullet item, right? And so hopefully you'll bear with me and realize that there are some unique challenges that maybe are not quite completely obvious to everyone, especially if most of your development practices were doing product development. All right, so before I go into too much detail, I want to, should you really listen to me about this? Well, I did say these are, this is only my opinion, not anybody else in the OWASP Foundation, not anybody else that's contributed to ESAPI. I want to make that clear, not my employers, current or former, right? But I have had, like Charles said in the introduction, 20 years of systems programming and 20 years of AppSec development, including developing several proprietary systems libraries, including one that was very specific almost to AppSec, very, very similar actually to ESAPI. And that's one of the reasons that I joined ESAPI in 2009. And ESAPI dates back maybe about 2 years earlier, at least as far as I could tell, going back into the mailing list archives, right? And then I was volunteered to be the co-lead in 2011. And the other thing is, lastly, I promise that this is a buzzword-free talk. Right, I'm not going to mention blockchain or AI or quantum computing, and I'm especially going to promise not to discuss quantum AI blockchain technology, which I'm sure someone is claiming to develop. I'm just mentioning these basically to help you fill in your buzzword bingo cards. All right, so the approach that I'm taking with this talk is that I'm going to discuss like three overall perspectives about process, about people, and the technical or architectural aspects of it. And then for each of those perspectives, it's going to have 4 sections: an overview, that basically briefly describes what that perspective is about, and then the good, what was done right, and the bad, what was done wrong, and then the ugly is kind of like neither really good or bad, but they were kind of ugly hacks that worked that probably could be improved at some point, or at least they're not elegant things, right? All right, so from the process perspective, the overview, so libraries and applications are different. They're different in design, right? You don't design libraries the same way. Libraries are extensible, applications generally are not. Testing is different as well, right? You might use something like, the unit testing is similar, but you don't have end user testing and stuff like that. Those aspects are completely different. Penetration testing, if you wanted to do it, would be different, right? You don't have anything to pen test necessarily, especially if you just have like interfaces. And I'm going to extensively talk on that. The documentation is different. It addresses a completely different audience. Instead of an end user, it's going to be addressing a developer of some sort, right? The other thing is you have a much higher chance of client lock-in. When somebody invests, to using your code and uses it all over their millions of lines of code, especially something like ESAPI, where you got like maybe you have JSPs, right? And you're using the output encoder all over the place to prevent cross-site scripting, right? And you got a couple thousand of those. It's really tough to like say, if you want to change the interface, oh, we made a mistake, we got to switch the order of these arguments or do something, right? That's not going to fly well, right? Security libraries versus other libraries, not eating our own dog food, and processes of effects of later process change. Those are the other things I wanted to mention. So I'm going to go into some of these others in detail. All right, so where was I? So yes, so the good thing is that things started out small. They had very simple expectations. They started basically as interfaces. And original vision, in fact, was basically only provide interfaces. Of course, the problem is, how do you test an interface? Well, you have to have some kind of executable code, at least to do, unit testing. And you kind of have to play around with the interfaces in some way, right? To see, are these the right interfaces to provide? And are we exposing the right things, or do we need to provide other interfaces and things like that? So in order to do that, they created a reference model, and that reference model got bundled with the interfaces, which in hindsight was probably a poor idea, but it happened. So the bad in the process. Well, I'm going to talk about these individual bullets later on, right, in the next couple slides here, so I won't belabor this one. But like the release migration, did we have enough feedback to do the from 1.1, or actually 1.4, I think was the latest 1.x release. Did we have enough feedback from users of that library? I'm not sure that we actually left enough time between the release cycles. But one of the things is you can't use like libraries just out of the box. You need to write code to give a feedback. It's not like, so it's hard to like, we did like release candidates, but I don't, I think the number of people using the release candidates was really, really small. So the other thing is going from one release, the one question that should have been asked is like, why even release 2.x? Because one of the major reasons of make a major jump in the semantic versioning is that you decide that these previous interfaces are not correct, and we want to deprecate them. And that's what basically a major change means on a major number, right? So you can basically decide that we're going to change the interfaces. Only we didn't, or at least not most of them, right? And that included even the broken cryptography that I took over, right? So we tried to keep the old 1.4 encryptor interfaces and just add new ones that were correct on top of that. Although I did deprecate the old ones and put in clear warnings, these are not safe and don't use them. But they think, oh, people have legacy code and they have encrypted stuff, and so we got to keep them. So like, okay, and shocker, it's like that actually was largely responsible for one of the two CVEs that were later discovered shortly after we released 2.0 release. So so the other thing was, this is what I meant when I said we were ignoring or not eating our own dog food, right? This could be perceived as kind of a do as I say, not as I do thing, right? But we always typically, as AppSec engineers, at least I do, I don't know, maybe the rest of you don't, but I'm like, I ask people like, well, what's your threat model? And what are you trying to, prevent here? What are your what's your attack vectors and things, right? Or state, well, are you doing, regular security code reviews? Or, you tell the testers or you tell developers that, your unit test should include more than just a sunny day path. And you should keep your dependencies up to date. And we didn't do a lot of those things, at least on a regular, consistent basis. I mean, we are much better now, in the last couple of years. We added roughly 1,000 unit tests and stuff to bring the coverage up significantly. But and in fact, the first unit test wasn't until, the first code review wasn't until NSA did the code review for us. And I will speak more to that later. All right, so this is kind of contrarian in a way that it seems it's not maybe obvious, but how is it, bad to have early success? Well, in this case, the encoder and the validator became really popular, and they dominated a lot of the requests and questions in the mailing lists. In fact, those parts of ESAPI became so popular that the encoder, for instance, was excuse me, was recognized as a mitigating defense in some SaaS tools like Fortify and Veracode, right? But that diverted the attention away from the things that, to me, if we're going to put out a reference model, you can't just have some that are really enterprise ready and others that are just toy implementations. And unfortunately, a lot of the stuff that really would have made ESAPI really, really usable is the authenticator and the access controller, for instance, only had toy implementations. And by toy implementations, I meant not that they didn't work, but that they didn't scale to enterprise levels because they were based on flat files. And, you're not going to add, 1 million users to a flat file. But if they would have done something like LDAP or something, right, they could have scaled it. In fact, that still hasn't changed, right? So. Hold on a sec. All right. The other thing is that there's little consideration given that the library development differs from application development, right? One of the things that Agile basically emphasizes is the constant refactoring, right? And you can do that if your end users happen to be humans. When your end users happen to be code, right? That's a little harder to do because humans have invested time in making that code their application that's using your library. And if you start changing interfaces, you're going to break client code, right? So that is a big problem, and you just cannot refactor the interfaces. You can sort of refactor, some of the other public classes, but part of the problem was that we found that there were people using some of the classes, but not through the interfaces. And in fact, they were doing that in some places where ESAPI was calling things like that and caused us problems. We had to rewrite things. I think it's bad because this was before Java 8 and Java modules came out. So it was kind of difficult to restrict that. But that was kind of an ugly thing that we just kind of relied on and crossed our fingers that people wouldn't do that too much. The other thing is how do you security test a security library, right? So unlike, say, something like a REST API, one cannot simply do general fuzzing of an SDK on interfaces because the strong typing in Java really makes that difficult, right? So if you want to basically say, well, this is supposed to be a integer. If I change it to a string, what happens? Or if I change, right? It just blows up, right? So it's that wouldn't even compile, right? So you just can't really test that way. And you can't test interfaces alone, as I said, because you have no executable code to test. All right, so jumping into the people perspective, right? This is about how the people involved with ESAPI affected the process and the product itself. and then the succession of leadership in particular. And I cannot, again, present you with a complete perspective of this, since I didn't join ESAPI until, as Charles mentioned, in June 2009. And even for that first year, I was almost solely focused, heads down on the cryptography aspects and trying to fix that. So the good, and I think I'm not going to be able to mention all the people, right? But we had great leadership, and first Jeff Williams, then Jim Manico, that kept it running smoothly and kept everybody happy, more or less. And we had a bunch of contributors. I mean, probably had a dozen contributors when I started. People like Dave Wickers and Arshawn and Mike Boberski and August, and I can't remember everybody's name. I'm sure, and I'm not trying to slight anybody, but just, I should have brought a contributors list with me to put up here. But so that was a good thing, right? We also had a lot of initial enthusiasm up through the 2.0 general availability release. And we did like several, it was a very long drawn out process for that 2.0 release, because we did, I think, about 6 or 7 release candidates. But there were, and the other thing that was really a positive was that it wasn't like people were fighting, on Twitter and arguing on Twitter in public and stuff. We did have a public mailing list that was not moderated, but the technical disagreements I felt were handled very professionally and transparently and civilly, right? So I think those were all very good things. So what was the bad? Well, I think one of the things is that the leaders who passed on succession to at least myself, I mean, both of these bullet points, these sub bullet points would apply to me. I'm not going to speak for Chris Schmidt. I think he did fine. But I think that like Jim Manico, who passed on the torch to the two of us, didn't take into consideration the good technical leaders in the business world do not necessarily translate to the FOSS world, because like in the business world, I can tell somebody to do this by a specific date, right? If they don't do it, then I can go speak to their manager, if I don't get cooperation. Here in the FOSS world, right, everybody's doing this as a volunteer, and they also have family obligations and stuff like that. So it's just a completely different mentality of motivating people. The second thing is that if picking the successor by stepping down and putting the two most committed volunteer or committers, most involved committers as co-lead is not necessarily a good strategy for success either, right? Which is, I think, what happened. I mean, Chris Schmidt and I, toward the end, were doing probably 75-80% of the commits between us, and most of the people kind of like fell off at the end, and we carried through all the way to the bloody end of the release. And Chris helped Jim, I think, with the release. But if you remember, if you're a dinosaur like me anyways, and you remember like some of the Looney Tune cartoons and stuff like that, those cartoons were like where there's like a army and a bunch of soldiers lined up in a line, and like the captain says, all right, all volunteers for this dangerous mission, please step forward. And all but one clueless sap basically takes a collective step backward, and leaving that poor sucker standing in the front saying, what just happened? I felt that was me when Manico selected Chris Schmidt to be his successors. I'm like, what the heck? I didn't volunteer for this. It's like, so, I mean, I felt like obligated to the project, and I wanted to see it succeed. And I felt if nobody else, I mean, I was like, can't, he says, I don't think anybody else wants to do it. And I'm like, well, okay, I guess I'll accept it, but whatever. So the people perspective, that's the bad. So next, the ugly. And yep, there's me. I've been told that I've had a face for radio or podcast, maybe. So seriously, after the 2.0 GA release, pretty much all the other help disappeared, right? So Chris and I basically handled about 98% of the work, and every once in a while, Jim Manico would pop back in and help us out on something. But I think the biggest problem to me was that the previous regime did not pass on any details of how to actually do a release. Today, I like to say that is well documented. I mean, in a 15-page document, right? Every little step that you have to take. But back then, it was like magic, and Chris had sort of figured out how to do it, but then he had to leave after a few years because he had other commitments, because he had made some job changes that just, pretty much consumed him. And so, I was kind of here left my own lonesome trying to figure out how to do releases when they were vulnerable dependencies that I had patched in the development build, but not I had no way to get them to Maven Central, and asked the mailing lists and stuff like that, and nobody really knew. So excuse me, I'm trying to get over COVID here, so I kind of got a cough. All right, so this is a discussion of the technical decisions around the architecture and the design, and kind of what I learned, the lessons I learned there. So the good, well, like I said, it started with interfaces, and it's always good to start with interfaces, and just kind of that's the way I design libraries as well, right? You sketch out some things, and then you start using, you write fake programs with them, trying to use those interfaces to see if they're kind of more or less, correct, and then change them and go back and forth, right? But essentially, you got to write at least some kind of a scaffold or something, because you can't actually execute it, the test, like I mentioned, right? And in fact, Jeff Williams, who started ESAPI in somewhere around 2007, basically after talking to him, his basic idea was actually to get the vendors to do the various reference implementations that were based on these implementations. And these interfaces were supposed to be sort of common and span across, multiple programming languages. And at one point in time, if you go back and look at ESAPI in 2009, we had an ESAPI, or at least either in progress or 2010, let's say. We had an ESAPI for C and ESAPI for C++. We had one for PHP. We had one for Cold Fusion. We had one for Apex. I think the Cold Fusion and Apex one are still done by their respective vendors. I don't know if they've kept them up to date, and I don't think they've ever updated them according to the 2.0 changes. But anyways, again, it's just it's really hard though that you can't really build an interface in a vacuum, and because you need to know if they're correct, right? I think the other thing that was good is we realized that some implementations were needed, even if they were only rudimentary. So that was a good thing. They did build those reference models out that they can sort of test with and things like that. And the property-driven approach to select a specific implementation, that was kind of the way that Jeff designed it, to basically allow somebody to put their own implementation in. And that was his vision, was basically somebody in an enterprise or a vendor would write a custom thing. For instance, somebody maybe Mozilla, who had an LDAP interface back then, right? They might have done an authenticator that basically hooked into that ESAPI interface, and just here's a library you could use, whatever. But that really never came to be. All right, so these, again, I want to emphasize, are my own opinion, not anybody else that necessarily was involved with ESAPI, but it is shared by the current crew and the current contributors, Matt Sile and geez, his name escapes me. I apologize. Anyways, So monolithic approach was bad, right? Singletons were a terrible idea. Some implementations were too successful too soon. I kind of already touched on that. Many implementations, many individual interfaces comprised of a single security control became bloated, and we had an uncontrolled growth of properties. And I'm going to speak to all those other things in the next slide, but I want to right now just kind of like say one thing about the singletons, which has always been my biggest gripe because it probably affected me more than anybody else, especially trying to test. Give you an example, right? If let's suppose you have an application that wanted to use ESAPI for encryption, and you had you're doing some new encryption, you wanted to use AES, but you had some old stuff that you had encrypted, right? And it was using triple DES. All right, so basically in ESAPI, you could not use the ESAPI encryptor, the Java encryptor implementation, right? It was a singleton, and it basically was a property driven thing. And the property you picked was, this is the cipher that I want to use, right? There wasn't any way to pass in the cipher that you wanted to use. And so what happened was, like, you either picked AES or you picked triple DES, and then you were stuck with it because it was a singleton. Right now, we had a kludge in the ESAPI class that basically allowed you to change the configuration temporarily, and then you could switch it back to the old one, but it was not thread safe, right? Well, that's not a problem, right? Well, yeah, because every web application which is what ESAPI was intended for, is multi-threaded. So yeah, it was a problem. All right, so I'll talk about the other issues now. All right, so ESAPI, like the monolithic approach, right? Why is that a problem? Well, ESAPI has 12 direct compile time dependencies, right? That pulls in 14 additional transitive compile time dependencies, right? So why is that a problem? Well, if you wanted to use something like the ESAPI encryptor, right, which requires no external dependencies itself, if you're comfortable with using SunJCE and the Java util logging for logging, right? It still has to pull in all 26 of those dependencies, even though technically it would not need any, right? So that's a problem. People didn't like that. Like, why do I have to pull in all these things, even though, right? So it's like, if we'd have split it up, it wouldn't have been that way. This has caused also problems with vulnerable dependencies that are past end of life, right? So like this second point, right, means that I've had, like, every time there is a new vulnerability in log4j 1.x, right, which is end of life, I have to research it and write up a security notice, and that has been pretty frequent thing because we cannot completely eliminate it, that log4j dependency, despite having the fact that we could support log4j 1 through an SLF4j bridge, right? Because if we did that, it would break backwards compatibility of people's code. They would have to, in other words, rewrite some code, right? So that's why we haven't just like removed it. But in my opinion, that was indication that there was something done wrong, right? Because we have to be able to design code so that we can at least remove unsupported libraries, right? Without the crew tax that we require right now, right? Like right now, if you want to use ESAPI, what I recommend to people is you say, if use SLF4j and log back or something like that, and then put in exclude log4j, whatever the version was, right? And then it just won't get sucked into your thing. But the problem is that, like, when they do things like dependency check or something like that, it'll still pick it up and flag it. So anyway, so yeah, that's the monolithic approach, right? So that's why I want to get rid of it. Bloated dependencies. Well, all right. So the encoder has 22 methods, right? Roughly half of those are encoders, and roughly half of those are decoders. The encoders are used very, very frequently. In fact, the encoder interface and the encoders like encode for HTML, encode for JavaScript, encode for CSS, all those things, those are the heaviest used. I mean, probably 80% of the use of ESAPI is through the encoder interfaces for those various encode for whatever methods, about which there's, a very small set of them. We could have, and we probably should have, separated out the decoder methods, because the decoder methods are rarely, if ever, used. I don't think I did a lot of code reviews when I was at Wells Fargo that used ESAPI. I don't recall ever seeing anybody using the decoder stuff. But 22 methods isn't so bad when you compare that to the HTTP utilities interface, which was kind of like a potpourri of anything and everything that had anything to do with HTTP. It had 60 methods, right? And many of them were very nuanced because they had like version, one or like 2 arguments, 3 arguments, 4 arguments, 5 arguments, 6 arguments, something like that, all the same method. And part of that was, obviously, because just Java's stupidity of not being able to support default arguments, which I thought was at least one of the great features of C++. It really, smashes down the size of things. And implementation wise, it wasn't a problem, right? You just basically would call some other implementation, something with a default argument. So the implementation was simple, but it bloated those interfaces and the methods and made it very complicated to read the Java doc and stuff like that. So the uncontrolled property growth. So adding a new property required this in the implementation class for security configuration interface, which was called default security configuration, right? You would have to add a public final string to represent the property. Optionally, you would put in a public static final string to represent the default value of the property. So in other words, if they didn't put it in their ESAPI properties file and somebody called it from their code, it would still have a default. And then you would have to put in a public method to access the particular property. So I have an example here with the force HTTP only cookies, right? Well, this alone might not have been a problem, except for everybody started saying, hey, I like this properties thing. Everything's property driven. It's easy to change it. We allow people to customize it. The end users and clients, they could set them to whatever they want and stuff like that. It's really flexible, right? But this interface started to get bloated as well. And I didn't count up the size of the interface for the security configuration interface, because right now, most of the stuff we've deprecated, and we suggest that, like, we have like a get string prop, get int prop, get bool prop, that type of thing, where you just pass in the property name. So that's sort of fixed, right? But it's like it just really makes it ugly and made it hard to maintain, and that was just the wrong way to do it. But yeah, these things, like this example that you're seeing right here, this is actually deprecated now, so in the interface. All right. So the other thing's ugly. We had this radical interdependency on ESAPI properties and logging and exceptions that was made apparent because we had this very tight coupling between security configuration interface, the logger interface, and enterprise security exception, and sort of by extension, transitively, the user, because the enterprise security exception did logging, right? And there was also, actually, depending on which exception you used, the intrusion detection stuff would come into play too. So that was kind of a problem. If you ever are interested in like looking at what I'm talking about more specifically, just pull down the ESAPI code sometime and run like Maven site, the MVM site command, and then look at the JDepends output, and you'll see what I mean. Second thing, there's too many ill-timed changes that were done at the same time. I mean, handling one change at a time is fine. Multiple changes at a time, bad news, right? So we were forced, because Google Code was sort of going away and it was using Subversion, and we looked for an alternative and ended up with, hey, well, everybody's using Git and GitHub, so let's make the switch. So, okay, that wasn't a problem to most of the people, because almost everybody, were using IDEs, but certain dinosaurs, me being one of them, are more fond of the command line, right? And I do almost all of my development from the command line, and I only break out an IDE basically when I need to either examine somebody else's code or when I need to break out a debugger, and that's pretty much the only time. Everything else is just, I just use gvim or something like that. So that was a problem, because I had to learn to get command line and what all the things do, instead of just clicking on different, I want to commit this or whatever. And then the other thing was changing from Ant to Maven. We did that at the same time that we moved from Google Code to Git, and probably it was the right move. I mean, Ant was getting old and stuff like that, but Ant works on basically explicit instructions of telling, you tell it exactly what you want it to do. In Maven, you pick a plugin, and the plugin figures out what you want to do. And so first, the first task is figure out which plugin that you should be using, right? And then the second task is make sure you got the plugin configured right with the right parameters. And then the third thing is you got to figure out like what the Maven goal is, and wire everything else up so that it comes out like when you do a test or a deploy or whatever, that it calls the right plugins and stuff. So that was, kind of a big pain in the butt. Anyways, and I had all kinds of questions about Maven in terms of like how to do deployments and stuff with it, and it just was very frustrating for me. We also trusted the NSA for a code review, right? I knew my limitations. Bruce Schneier has said that basically anybody can write cryptography code that they think is secure. There's a story about Ron Rivest, actually, that basically he spent like, you all heard of RC4, no, RC2, RC3, I think it was, that basically he designed after RC2 that never became widespread, because he went to some crypto conference and he gave a talk on it, and by the end of the conference, supposedly somebody had cracked it, right, after all those years. So it's like, I am no Ron Rivest, obviously. So I felt uncomfortable of just like nobody else that was working on ESAPI, knew cryptography. I made a call out to the leaders list or some of the general ESAPI lists, and nobody responded. I got one response. I put it out on some public mailing lists, and one person said, yeah, I'll review it for you for $30,000. Well, we only had it was probably only like less than 1,200 lines of code. I didn't think that was a very good deal. So Dave Wickers basically knew somebody at NSA, and they said, yeah, they have this thing that like sometimes reviews open source code, and they would do it for us. So they decided not to just do a code review on the crypto, but on the whole thing, right? And I interacted with them, and they found like, oh, you should use I don't know, SHA 256 here instead of SHA 128 or whatever, instead of SHA 1. But to our credit, this was pre-Snowden days, but that CVE that was discovered that I mentioned earlier, CVE 200 2013 5679 was there because of a 1.4 backward compatibility interface, and that should have been spotted by anybody in NSA that was clueful of cryptography. Basically, it found a way to bypass the integrity checks with the HMAC, and bypass that. And I just like really upset that they didn't find that. I mean, I suppose it's plausible deniability, but after hearing the story about the NSA backdooring the dual EC DRBG, the elliptic curve deterministic random bit generator, that then they had NIST advertises the greatest thing since sliced bread, it became obvious that our trust was misplaced in NSA. So, and we also had a bunch of open issues that presumably were important, that are never addressed. And then we have rules for locating ESAPI properties that are just, I think, way too complicated. So like regarding the issues that were never addressed, right? If you add these up, we have like 112 potentially important issues that have been ignored or forgotten or whatever, right? Swept under the rug, I don't know. But as far as I know, none of them have ever been like turned into GitHub issues and worked on. And, presumably they were at least important to the author at one point in time, right? So I have no idea. I mean, I have not even looked. There's so many of them that I've not even looked through all of them. Now, Truth in Advertising, all the ones that are listed as open issue and discuss were ones that I added as flags, or basically with the expectation that we were going to do code review and I was going to get feedback on these things. But like the NSA never even asked about them. I asked about a few of them that were there. There used to be like more open issues and discuss things, and I deleted a couple because I got to talk to some of the NSA people. But if we're not doing these things, it feels like nobody's really watching what's going on, right? At least to me. So the other thing is finding the ESAPI properties, or how do you locate that ESAPI properties file? Okay, so I want to say right now, the single most frequently asked question on Stack Overflow about ESAPI is, help, my implementation can't find the ESAPI properties, right? And it's because it's really complicated, right? It's documented not in the interface, right? Because hey, the interface shouldn't tell you how to find it, right? It's the implementation that decides that. But people don't normally go and look in the default security configuration, which is the implementation. And one of the few things that you really can't change the implementation of unless you want to rewrite some significant parts of ESAPI, right? But the rules, just so you know, roughly are: you first look inside of a directory that's set with a call security config. Well, not security config. Well, yeah, it's actually, there's a ESAPI dot something. I think it's ESAPI dot security configuration dot set resource directory, full path name or something like that. So you can do that, or you can, and you'd have to like do that in a startup class of some kind before you use ESAPI ever. Or you can set it with a system.get property. You can set the property org.owas.esapi.resources to some directory that it'll look in. Or you can set, it'll look also, if it doesn't find it from those first two steps, it'll look under the system property user.home under the /esapi directory, or then for backward compatibility, the /.esapi directory. And if it doesn't find those, then it'll look under the first ESAPI directory for the class path, on the class path, for several different class path loaders, which I've basically excluded here just to avoid clutter,
right? But there's like, I think 3 or 4 different class path loaders that it looks through. And if it doesn't find it there, then it goes back and tries again with .esapi, which I'm not sure why anybody would put that in a jar or a war or whatever, but I mean, a dot directory, but I suppose they could. Anyways, so, if that doesn't, find, if it does get found, it stops looking and it logs it to standard output. But a lot of people have disabled that standard output logging because it's this noisy, especially when you run tests. So in conclusion, right, I think monolithic libraries are a thing of the past. Back when we started this, when this was started and originally designed in 2007, we didn't have things. Well, I mean, there may have been things like, there certainly was micro architectures and micro kernels and things like that, but they weren't as popular as they are today. We didn't have microservices and things like that. I think that the big problem with monolithic libraries is it just flat out makes things too brittle. It makes things too hard to change. And in ESAPI 3, which we have lovingly started calling 3SAPI, it's going to be done very differently. And that's kind of another talk. But and shout out to oh yeah, that's his name, Jeremiah Stacy, who's the other major contributor to, besides Matt Seil. So a shout out to Jeremiah for that clever name. Unfortunately, we won't actually be able to use it in a formal name, because you can't start like a package name with, like, can't do org OWASP.3SAP, because you can't start with a 3, and we don't really want to spell it out. So anyways, so that's it. Anybody questions? Are we about at the question time, Charles?